we're going to play with correlations a little bit and practice with them. I would suggest that as we go through this video that you split your screen and open SPSS if you can, and pause the video where you want to and follow along and do exactly what's demonstrated in the video. So in this practice, we've got a company that manufactures widgets, and they want a paper and pencil screening tool for when they hire people, and so they need to know if that tool is correlated with their measurement that they make for how productive their employees are. So widget manufacturing will implement a paper and pencil screening tool for hiring production floor employees. Productivity is measured as the number of widgets made per day by each employee, called performance evaluation. There are two possible tools called Test 1 and Test 2 in this report. In order to see which test has the strongest correlation with the actual employee productivity, a Pearson product moment correlation was done with Test 1, Test 2, and performance evaluation. Descriptive statistics provide the measures of central tendency for all three tools. In SPSS, here's the variables view, and I've set up 4 columns. So there's going to be one where I identify the employees. This column is going to give me their number of widgets they make each day. This is their score on Test 1 and their score on Test 2. And the data looks like this. Now you may want to pause at this point and put this data into SPSS for yourself. Let's look at employee number 6. Employee number 6 makes 52 widgets each day, scored 14 points on Test 1, and 29 points on Test 2. In SPSS, I go to Analyze, and then choose Descriptive Statistics and down to Descriptives. Let me get an eraser and get rid of that. Okay. Now I've got the dialog box that pops open, and I use the arrow to move the variables over that I want to run my descriptives on. Notice there's a little box down here that tells SPSS to save standardized values as variables. That tells SPSS to figure out what the z-scores are for each of these variables up here. So performance evaluation is a different kind of test than Test 1 or Test 2. So standardized value would be really valuable if I'm going to be comparing these things. Inside the options, I want the mean for each of these variables, the standard deviation, of course, because the mean isn't very valuable without it. And then I want to know that my variables are normally distributed, what that distribution curve is going to look like. Because I checkmarked that little box about standardized variables, SPSS makes a new column for each of these variables. So if I look at employee number 5, this employee makes 98 widgets a day. When that 98 is converted to or transformed to a z-score, it tells me that this employee is performing 1.5 standard deviations above the mean. So this is a high flyer. Look at employee number 6. They're performing 1.3 standard deviations below the mean in how many widgets they make a day. Okay, in this descriptives that SPSS gives you, notice that you get your means and, of course, their standard deviations that go with them. And then it gives us, over here, we get our distribution. Is it skewed or is it within the range of normal? Notice that none of these are outside the range of 2 plus or minus. So all of these are within the range of normal, even though they show that they're negative, Distribution is very forgiving. So these are all considered within the range of normal. I'm going to create a table now that gives my measures of central tendency, my mean and standard deviation. These are my raw scores, and I simply get the information from SPSS and put it down here. Now, notice that I have used 2 decimal places. I go to the hundredths. I'm consistent across the whole chart. Then I add in my table, this should still be table 1 probably, but that's fine. And I put my standardized scores in here. Missing, of course, a parentheses. Yeah, you always find something when you proofread, right? Okay. Notice that the mean and the standard deviation become standardized. And if this is still confusing to you, you need to go back in your textbook and read about standardized scores so that you know what this means. Here's how I'd write it up. The measures of central tendency for all 3 types of evaluations are displayed in Table 1. The performance evaluations had the highest mean, a mean of 73.80, standard deviation of 16.1, followed by Test 2, mean of 38.5, standard deviation 8.63, and Test 1, mean of 16.8, standard deviation of 4.76. And then I would write up that that the means were 0 and the standard deviations were 1 in Table 2. Now I've got to address the distribution. None of these ranges down here are outside the range of normal. Remember that normal, it's still considered normal if it's within a -2 all the way up to a +2. So our data is well within the normal range. So I would simply write the distribution for all evaluations were within the range for a normal distribution. Standardizing the scores did not change the distribution. All standardizing scores does is tell us how many standard deviations above the mean each score is. Now I'm ready to run my correlations. So I go back up to Analyze in SPSS, Correlate, and Bivariate. And I get a dialog box that lets me move the different variables over into where I'm going to have it do its analysis. Notice I chose to do a Pearson product moment correlation. This data is on an interval or a scale continuum, so I can use Pearson. If this data was ordinal, if I had ranked the employees on the number of widgets they made, then I would choose to use a Spearman-Rowe correlation. And SPSS gives me a correlations output. So let's take a look at this really carefully. Each of the tools is correlated with the others. So here's performance evaluation being correlated with itself, with test 1 and with test 2. Now obviously you can go vertically if you would rather. You get the same information both ways. So let's look at this. This is telling us that the correlation between performance evaluation and performance evaluation is 1. Well, of course it is. If you're going to correlate something with itself, it had better be 1. That's not very useful information. Now let's look at test 1 correlated with performance evaluation. Here we find that the correlation is 0.59. The significance, the P, is equal to 0.02, or 0.72. 0.072 is above, it's larger than my cutoff, my alpha of 0.05. So I say that the correlation was moderately positive, but not statistically significant. Next one, performance evaluation in test 2. Here my correlation is 0.91. P is less than 0.001. Never, ever report P equals 0.000. And it's a statistically significant correlation, and it's strong and positive. 0.91 is a great correlation. Now test 2 and test 1. My correlation is 0.77. The p-value is 0.009. So again, this one is statistically significant. Statistically significant correlation was strong and positive. Correlation of 0.77 is pretty good, isn't it? Now I've got to write this up for my report for the widgets manufacturing company. The Pearson correlations among the 3 types of evaluation are displayed in Table 2. Only 2 of the correlations were statistically significant. The relationship between test 1 and test 2 was strong, positive, and statistically significant. R equals 0.77, P equals 0.009. Higher scores on one test were associated with higher scores on the other tests. The relationship between test 2 and the performance evaluation was the strongest. It too was positive and statistically significant. R equals 0.91, P less than 0.001. High scores on test 2 were related to high scores on the performance evaluation. The final correlation between the test 1 and the performance evaluation, R equals 0.59, P equals 0.072, was moderate and positive, but not statistically significant. Please note these statistical statements that are placed in the narrative. These are critical. This is the formal way to say what the correlations were, and they are really, really important. Notice my table 2 is a matrix. It's shaped like a triangle. And I've put hyphens in here where performance evaluation correlated to performance evaluation. Don't use a 1. That doesn't give us any information. We're not interested in the correlation with something with itself. And I've indicated which ones are statistically significant right in my chart at a glance. Now I'm going to use the standardized scores. And lo and behold, my matrix doesn't change. The correlations do not change when you standardize the scores. So I'll add that to my narrative. As shown in Table 3, the correlations did not change when the scores were standardized. When we standardize scores, we don't change the value of the score. We change its relationship in standard deviations. We just report it a different way.